Hello everybody. In this lecture we will discuss the refraction of light through a spherical surface. First of all, we will discuss the refraction through a convex refracting surface, and when light is traveling from rarer to denser medium. And under this heading we have the first case 1, that is when image formed is real. Okay, then we will discuss when image form is virtual, and then we will discuss from denser to rarer medium, so on and so forth, and finally we will go to the concave refracting surface. Okay, let me draw the diagram very quickly. Okay, so you can see here in this diagram, this surface here, this is the convex refracting surface. The name of the surface, I have named it as XPY. Okay, and you can see these shaded region like this. Why do I shade? I shade this part just to show that this is the denser medium and the refractive index is mu2. The region surrounding it, that is the rarer medium, it has a refractive index mu1. This rarer medium, this for example, this may be made of glass, and this rarer medium, it may be air, or it may be water, or it may be any other medium which is rarer than this. Understand? Not necessarily that this will always be glass and this will always be air. Understand? So in this diagram you can see this point here, this point O is the object, and this is a point object. What is it? It is a point object. A point object O is placed where? On the principal axis. Okay. Now rays of light from this point object, can you see the white color ray? Those are the rays of light. I've drawn two rays of light. So there is one ray of light that will go travel along the principal axis. Okay, it will travel straight along the principal axis like this. And there's another ray of light, OA. Let's call this point as A. Let's call this as A. This ray OA, that is the incident ray. Okay, that's the incident ray, and it incident on this surface at the point A. Now what do? We join the center of curvature C with this point A, and because this is the center, if I join, then this looks like the radius, isn't it? AC looks like the radius. So this radius will be perpendicular to the surface. So if I extend this in this direction, then this dotted line will give us the normal. Understand? So this OA is the incident ray, the normal. So what will be this angle? This angle here will be the angle of incidence. I call this angle of incidence as I. Okay. Now this, since it is going from the rarer medium to the denser medium, what will happen to the ray of light? This ray of light, it seemed to be going in this direction, but then it doesn't go in that direction. It bends towards the normal, right? So it bends towards the normal like this, and the two rays, this refracted ray and this ray, they meet at the point I to form the image, the point image at I. Understand? AI here is the refracted ray. This is the normal. So what is this angle? This angle here, this angle between the refracted ray and the normal, that is the angle of refraction denoted by R. Is it clear? Let's call this point as M. Okay. Now you can see these angles alpha, beta and gamma. So always starting from the object. The object here is O. The object is O. So therefore we name this angle as alpha. Second is the image. We name the angle where the image is formed as beta. And lastly, the center of curvature, we name this angle as gamma. Alright, so just to draw this ray diagram also, it has been asked in the exam. Okay, and what about these distances? Distances are always measured from the pole, isn't it? So from the distance from O to P, from the object to the pole, that is the object distance U. From P to C, C here is the center of curvature, so from the pole to the center of curvature, that is the radius of curvature R. from P to I, from P to the image, that is the image distance V. Is it clear? So I want you to practice drawing this diagram nicely, and understand, when you draw any diagram you have to understand. Don't just draw the diagram for the sake of drawing the diagram. Okay, right. Okay, so what shall we do? Let us apply the Snell's law. Okay, but first of all you have to write the description of the diagram. You say that let xpy be a convex refracting surface having a refractive index μ2. It is placed in a rarer medium having refractive index μ1. O is a point object. Rays of light from the point object after refraction through the surface forms a real image at I. Is this a real or a virtual image? This is a real image, okay, at I. Okay, so that is the first thing that you have to do. By Snell's law, we have, you remember how we wrote Snell's law? So here it will be what? It will be μ1 sine I is equal to μ2 sine R. Yes or no? So because why? μ1 and I, they are on the same side, on the same medium. Yes, on the same side of the pole, they are on the left hand side. So μ1 sine I is equal to μ2 sine R. So we have μ1 sine I is equal to μ2 sine R. Let's call that equation 1. But since I and R are very small, then sine I, this is nearly equal to I itself, and sine R, this is nearly equal to R. Okay, so this is an approximation. We are using the concept from maths. We know that in the topic called limits, when I is very, very tiny, when this angle is very tiny, let's say sine theta, if theta is tending to 0, okay, then in that case this sine theta will be equal to theta itself. Okay, so that is from the chapter of maths called limits. Okay, so similarly sine R will be nearly equal to R itself. So therefore the above equation will become how much? Will become μ1 I is equal to μ2 R. Okay, let's call this equation 2. Alright, now let us look at this diagram once again. Now in this diagram, if you look at this angle here, ACO, in this angle ACO, isn't I the external angle? And the opposite internal angles are alpha and gamma. Yes or no? So let me just draw a rough diagram here very quickly. I have this this diagram, this dotted line, and then I have something like this, This point is point A, this is angle I, this is point O, and this is point C. This is angled alpha, and this is angled angle gamma. So we know that the sum of the opposite internal angles are equal to the external angle. That is the concept from geometry. So here I will be equal to alpha plus gamma, is it not? And similarly, if you look at this angle AIC, AIC is something like this. The dotted line is something like that, and you have this line like this. This is A, this is I, this is C, this angle here is gamma, this is angle R, and this is angle beta. Similarly, gamma here, since gamma is the external angle, it will be equal to the sum of R and beta, R plus beta. Okay, so what do? We say in triangle AOC, in triangle AOC, what did we have? We have I is equal to alpha plus gamma. I is equal to alpha plus gamma. Let's call this some equation 3. And in triangle, which triangle? AIC, gamma is equal to R plus beta. AIC, gamma is equal to R plus beta. So from here, R will be gamma minus beta. Call this some equation 4. So let us put equation 3 and 4 in equation 1. Putting 3 and 4 in 1, we get mu1 instead of I, you write alpha plus gamma is equal to mu2 instead of R, you write gamma minus beta. Okay, call that equation 5. All right. Okay, now here again, since alpha, beta and gamma are small angles, then we can approximate, we can say that alpha, this will be equal to tan alpha. Okay, beta, this will be equal to tan beta, and gamma, this will be equal to tan gamma. Okay, so instead of alpha here, we will write tan alpha. So let me just continue here. So therefore, this equation 5 will give us mu1 tan alpha plus tan gamma is equal to mu2 tan gamma minus tan beta. Okay, do you understand this approximation? Again, this is an approximation we are using the concept from maths, okay, because this angle alpha is very tiny, very small. All right, so let us not try to understand so much about the maths, about why this is happening like this. Let's just assume, let's just take it for granted, okay, that maths is not lying us. All right, so if this angle is small, then alpha will be, we can replace it by its tangent. So alpha will be tan alpha, similarly beta will be tan of beta, and gamma will be tan of gamma. So in this in the values of alpha, beta, gamma in this equation 5, we write the tangents. Okay, now look at the diagram and tell me what is the value of tan alpha. Tan alpha, where is this angle? Tan alpha will be perpendicular by base, so that will be AM by OM. So this will be AM by OM plus tan gamma. Tan gamma will be what? This angle, tan angle will be perpendicular by base, AM by MC. This will be AM by MC. Mu2 times tan gamma, again this is AM by MC, minus tan beta. Tan beta, beta is this angle, so tan of this angle will be AM by MI. AM by MI. Okay, so we have, okay, do you agree or not? AM will be cancelled. Yes, and I multiply this mu1 inside, I get mu1 by OM plus mu1 by MC is equal to mu2 by MC minus mu2 by MI. Okay, let's call this some equation 5, 6. Okay, take another layer. Yeah. Alright, now here let us look at what is the value. Alright, not this one. Okay, now what is OM, MC and MI? OM here. If you look at this diagram, OM, that is very approximately equal to OP, right? OM is nearly equal to OP, but what is the value of OP? OP is U, okay, and it is plus or minus U, that will be minus U. Alright, why minus U? Because it is on the left hand side. Okay, OM is nearly equal to OP, then okay, let us write that down here. But OM, this is nearly equal to OP, which is equal to plus U. What else? MC, that is nearly equal to PC, which is equal to plus R. This is minus U, sorry. MC nearly equal to PC, that is R. MC nearly equal to PC, that is equal to plus R. Sorry, this is actually minus U. Minus U. And again, let us look. MI, that is nearly equal to PI, which is equal to plus V. MI, PI, so that will be M, undo, MI nearly equal to PI, which is equal to plus V. So therefore, where is that equation once again? This equation, let us put the value of OM, MC and MI. So this will be mu1 by OM, mu1 by OM. So therefore you will get mu1 by OM. OM here is minus U, plus mu1 by, what was the thing in the denominator? Mu1 by MC. Mu1 by MC, but MC here is plus R. So this will be mu1 by R is equal to mu2 by MC. So that is also mu2 by R minus mu2 by MI. MI here is V. Okay, so let me take this to the other side. Let me take this part to the other side. Okay, and I'll take this part to the other side. So therefore I will get this minus will become plus. So I will get mu2 by V minus mu1 by U is equal to mu2 by R. Take this to the other side again, minus mu1 by R. Okay, am I making a mistake? No. So this gives us mu2 by V minus mu1 by U is equal to, wait, did I make a mistake here? Yeah, no. So this will be mu2 minus mu1 by R. This is the required expression. That's the required expression. Okay, so this expression, to derive this expression, you have to again go by right from the beginning. So what do we do? First of all, we draw this diagram. Okay, let's say you have this diagram. Okay, so you have to understand how to draw this diagram also. And then after that, what do? You take by Snell's law. Okay, by Snell's law, we have this by Snell's law: mu1 sine I is equal to mu2 sine R. Then since I and R are very small angles, then we can replace sine I by I and sine R by R. So I get this equation. Then in this triangle, if you look at this diagram, in this triangle, I here is the external angle, so I will be equal to alpha plus gamma. So I get this equation. In this triangle, gamma here is the external angle, so gamma will be equal to R plus beta. Then instead of I and R, we replace it with these two equations. Okay, so we get this equation. Now after getting this equation, we replace alpha, beta, gamma by their tangents, and we get this equation. Then from the diagram, what is tan of alpha? It is equal to AM by OM. Tan of gamma is equal to this. Then I can cancel AM, 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 AM here. I multiply mu1 inside, so I get this equation. And then I put the values of these distances, OM, MC, and MI. And then finally, I get this equation. Okay, right, so practice and derive this equation nicely, because this has been asked in the exam. Thank you.